Situations where the center of gravity man lies outside of the body. These are useful for the ninth standard. First answer is center of gravity of a human being is located interior to the second sacral vertebra. Center of gravity of man lies outside the body in the following situations. First one is while doing sit-ups while carrying a load like bucket full of water with one hand, while walking on a narrow base like walking on a rope or a pole on narrow wall, etc. Next, while walking with one leg, as age increases, its position changes. Next, where does the center of gravity of the atmosphere of the Earth lie? The Earth atmosphere is about 1,000 kilometers thick, but most of its bulk is contained in the first 11 kilometers above the Earth's surface. Since the Earth and its atmosphere are roughly spherical, the center of Earth is also the center of gravity of the Earth's atmosphere. So ఇది సెంటరే సెంటర్ ఆఫ్ గ్రావిటీ అనమాట. ఎక్స్ప్లెయిన్ వై లాంగ్ పోల్ ఈజ్ మోర్ బెనిఫిషియల్ టు ద టైట్ రోప్ walker if the pole has a slight bending. You must have noticed the circus artist doing rope walking. During this act, they carry a long bamboo pole in their hands. The reason for this is that the line joining the center of gravity and center of equilibrium must fall within the rope for achieving the stable equilibrium. Thus, when an artist finds that he is falling towards left, he shift bamboo pole towards right so that his center of gravity stay undisturbed. Thus, he can balance himself on the rope. Next application question. So a car moves with constant speed of 10 meter per second in a circular path of radius 10 meter. The mass of the car is 1000 kg. How much is required centripetal force for the car? Speed of the car V equal 10 meter per second. Radius of the path R is equal 10 meters, and weight of the car M equal 1000 kilograms. Centripetal force required Fc equal mv square by r. Mass ఏమో 1000 kg, 1000 into v 10 meter per second కదా, 10 into 10 by r radius 10. So then 10,000 అంటే 10 to the power of 4 న్యూటన్స్ అని చెప్పవచ్చు. సో ఫోర్స్కి యూనిట్స్ వచ్చేసి న్యూటన్స్, 10 to the power of 4 న్యూటన్స్. So the required centripetal force is provided by the friction between the tires and of the car and the road. Next question: what is the speed of an apple dropped from a tree after 1.5 second? What is the distance will it cover during this time? Take g equal 10 meter per second square. Here answer: an apple is dropped from a tree. So initial velocity u equals 0. Time t is equal to 1.5 seconds. Then a equals g 10 meter per second square. Final velocity v equal water. V equal u plus at. Substitute in this. U and the initial velocity 0 plus a equals z కదా. So 10 into t 1.5 seconds. So 0 plus 0.0 plus 1.5 15 meter per seconds. 10 into 1.5 equal 15 కదా. So 15 meter per second. Distance covered is equal ut plus half at square. U initial velocity 0 కాబట్టి 0 into t 0 అవుతుంది. So 1.5 plus of initial velocity 0 into t equal 1.5 plus 1 by 2 z a అంటే t z 10 into 1.5 into 1.5. So here answer is a 0 plus 0 plus 5 into 2.25, that is 11.25 meters. Next question: a ball is projected vertically up with a speed of 50 meter per second. Find the maximum height, the time to reach the maximum height, and the speed at the maximum height. Z equal 10 meter per second square. Initial speed u equal 50 meter per second, z equal 10 meter per second square. Maximum height reached by the body h equal u square by 2z. U means initial velocity 50, So 50 into 50 by 2 into 10 is equal 10 kada. So 125 meter. That is the maximum height reached by the body. Next, time taken to reach the maximum height t equal u by z, and initial velocity 50 by 10 is equal to 5 seconds. The time taken to reach the maximum height is equal to t is equal to u by g. 50 by 10 equal 5 seconds. After reaching the maximum height, the velocity becomes 0. Two spherical balls of mass are 10 kg each are placed with their centers 50 centimeter apart. Find the gravitational force of attraction between them. Masses of the balls m1 and m2 is equal to 10 kg each. Distance d equal to 10 centimeters is equal to 0.1 meter. And gravitational force of the attraction between them is equal F equals into m1 into m2 by d square g into m1 masses వచ్చేసి 10 kg 10 kg 10 into 10 by d square, అంటే distance 0.1 meters, 0.1 into 0.1. So 10 square by 10 to the power minus 2 is equal g into 10 to the power 4 newtons. So force of gravity is equal to g, gravitational constant, into 10 to the power 4 newtons. Find the free fall acceleration of an object on the surface of the moon if the radius of the moon and its mass are 1740 kilometers and 7.4 into 10 to the power 22 kg respectively. Compare these values with the value with the free fall acceleration of the body on the surface of the earth. Here, the radius of the moon is equal to 1,740 kilometers. Meters law converges to 140 into 10 to the power 3 meters. Mass of the moon equals 7.4 into 10 to the power 22 kg. And the gravitational constant 6.67 into 10 to the power of minus 11 Newton meter square kg minus 2. Free fall acceleration of a body on the surface of the moon. Free fall acceleration gm is equal to capital Gm by r square. So capital G value and the gravitational constant value 6.67 into 10 to the power minus 11 into m mass and mass of the moon 7.4 into 10 to the power 22 by radius 1740 into 10 to the power 3 into mali radius kada 1740 into 10 to the power 3, that approximately 1.63 meter per second square ఉంటుంది. That is the acceleration of the moon by free falling అనమాట. 1.63 meter per second square approximately. Next, the free fall acceleration of the body on the surface ge is equal to the free fall acceleration of the body on earth surface ge అంటే ఈ అంటే ఎర్త్ సర్ఫేస్ మీద ఫ్రీ ఫాల్ యాక్సలరేషన్ వచ్చేసి 9.81 మీటర్ పర్ సెకండ్ స్క్వేర్ అనమాట. సో ఇక్కడ ఫ్రీ ఫాల్ యాక్సలరేషన్ ఆఫ్ ద మూన్ 1.63 by free fall acceleration of the earth ge అంటే 9.81 1 by 6 approximately అనమాట. అంటే free fall acceleration on the moon is 1 by 6th of the earth. అంటే ఎర్త్ యాక్సలరేషన్లో మనకి మూన్ దగ్గర 1/6 పార్ట్ ఉంటుంది అనమాట. చాలా తక్కువగా ఉంటుంది ఫ్రీ ఫాల్ యాక్సలరేషన్ కంపేరింగ్ టు ఎర్త్. A ball is dropped from height. If it takes 0.2 seconds to cross the last 6 meters before hitting the ground, find the height from which it is dropped. Take g is equal 10 meter per second square. For last 6 meter distance to travel, s equal 6 meters, u equal, we don't know, t equals 0.2 seconds, a equal z, that is a 10 meter per second square, s equal ut plus half at square. Here u into 0.2 plus or half the a equals z కాబట్టి 10 into 0.2 whole square ఇక్కడ. సో ఇక్కడ distance already we know that 6, distance is 6. So 6 into 0.2 into u plus 5 into 0.04, that is 6 minus 0.2 equal 0.2u. Next, so 5.8 is equal 0.2 u, that is implies to u equal 5.8 by 0.2, that is a 29, u equal 29 meter per seconds.